Good morning and happy Friday, the end of our third week away from school. This is the note sheet that I posted yesterday. I just wanted to add a couple hints and maybe do a couple problems for you. These are just your ratios. These are all going to be, opposite over adjacent, opposite over hypotenuse. And then these are just the reciprocals. Sine and cosecant should be reciprocals, cosecant, secant, tangent, and cotangent. You use the Pythagorean theorem to find the third side, making sure that you always use the side across from the right angle as the hypotenuse or the longest side. Now 2 was a little interesting, so I thought I'd just show you a couple of the answers to some of these. They gave you triangle ABC. C is the right angle, so I labeled that as the right angle. AB, it doesn't matter whether A is up top or down below. It can be AB or BA, doesn't matter, but C has to be the right angle. And that would then make AB the hypotenuse. CB is this adjacent side to that given angle. And they want us to express all 6 trig ratios using angle B. So I put a little marker there for angle B. And express in simplest radical form. So this is one where this is not a special right triangle or a Pythagorean triple. It has a root in it. So using the Pythagorean theorem, there's your hypotenuse. This is the adjacent side, that's the opposite side. And I just used the Pythagorean theorem to find that third side. That is simplest radical form. It can't be reduced because 7's a prime number. I didn't find all 6 of them, but I just found a couple of them, the ones that had to be rationalized. So I looked at sine first because sine is from angle B, opposite over hypotenuse, so there's my sine. Cosecant, I'm just going to cover this up for a minute, is the reciprocal of sine. So that's 4 over root 7. And if you remember, I believe it was unit 2 when we did radicals way back, you can't leave an irrational number in the denominator of a fraction because we don't know what that is. So you rationalize this by multiplying numerator and denominator by root 7. And this is your cosecant. If I can find a pencil right here, I'm just going to box it in. This is your final cosecant. And then cotangent was the other one that wasn't, that had to be rationalized. Remember, tangent is opposite over adjacent. So cotangent would be adjacent over opposite. So that's your cotangent. Again, it has a root 7 in the denominator. Re-rationalize it. And the cotangent is now 3 root 7 over 7. And that's how you would rationalize any trig ratio that has a root in the denominator. Now on the second page, number 3 I didn't talk about in the video, and that just uses your calculator. And this is the first time you have to make sure that your calculator is in degrees. When you hit a sine, cosine, or tangent button, and they give you degrees, you have to make sure your calculator is in degrees. And if you just turn your calculator on, sorry, I was doing a little stats here yesterday, and you hit mode, you'll notice that one of the very first ones right there, right under, oh, it's there, whoops, there it is. That's radians, that's degrees. If you clear your calculator, it always goes back to radians, so make sure it's in degrees. Now the problem here is we don't have a secant button, or a cosecant button, or a cotangent button. All we have are sine, cosine, and tangent. So because secant is the reciprocal of cosine, you just type in 1 divided by cosine 45, because secant is 1 over cosine. And if you type that in, you should get this number. Remember, secant, cosecant, and cotangent all have the hypotenuse in the numerator. So they're all going to be numbers that are greater than 1. Cosine 45, if I was to type that in, let me see, I'm going to clear this. Cosine 45, that is adjacent over hypotenuse, and the cosine, sine, should always be less than 1. So that's a way that I always check to make sure that my calculator is also in degrees. Now, number 7 wanted you to draw and label an appropriate right triangle. So I just did part A, because part A was the first one that could actually have a root that could be reduced. So here's my triangle, my right triangle. This is sine. So sine, with respect to this, that's a little theta there. I probably didn't write it quite as neat as I could. That is opposite over hypotenuse. That's your sine. Hypotenuse equals the sum of the other two sides. This is the adjacent side. So if you move the 7 squared over, I'm going to solve for that small side there. That gave me adjacent side squared equals 72. Square rooted both sides. Now that's a root that can be reduced. 72 is 36 times 2. Reduced square root of 36 is 6. And that's your third side. So when they say draw and label, they want all the 3 sides labeled. You find the third side and try to reduce it. If it's a root, try to reduce. And finally, this is the very last one. This is D. This is 5. Find the value of the trig function indicated. And these ones shouldn't have been too bad. This is, I will tell you that here, this is a decimal. I would put it in the calculator because these are all trig ratios. So when you put that 1.75, I'm going to put it in my calculator, and ratios are all fractions. So I'm going to put that in, and then I'm going to math frac it. So I'm going to write this. I didn't do this for you, but I would put cosecant theta equals 7 over 4, and then you can find from there, I always go back to sine. Sine would be 4 over 7. There's your opposite side. There's your hypotenuse. You can do your little right triangle. Whoops. Find the adjacent side, and then you can find cosine. But do them in fractions, not decimals. And then finally on D, it said find secant given sine. Now this is something kind of like what we had up on the first page where it was 3 root 7 over 7. This has also already been rationalized, but it's still a sine. So here's my little right triangle. I decided to use this angle. You can use either one, but I always like the one in the bottom corner. Sine is opposite over hypotenuse. There's my hypotenuse. There's my opposite. There's my adjacent. I subtract this over, and you can plug this whole thing in your calculator. I did it one number at a time, 13 squared. Make sure this is in parentheses and you square them both. So that's 3 times root 3 squared should give you 117. Or you can plug this whole thing in and it should give you 52 if you go from left to right. That's your adjacent side squared. The little squared is right up there. You square root it. You get the square root of 52. 52 has a perfect square factor of 4. And that's where I got my third side. Now I know this is kind of a lot of work for this little sheet of paper, so hopefully you have paper of your own at home. And I also write big. Some of you that write so teeny tiny, maybe you can fit it, but I'd suggest using some of your own paper so that you can spread it out and really see what's going on. Secant is the reciprocal of cosine. So I found cosine. That's my adjacent over hypotenuse. And then I just reciprocated it. That's 13. Here's the reciprocal. 13 over 2 root 13. I now have to get that root 13 out of the denominator. I multiply by root 13, root 13. Root 13 times root 13 is 13. When you square a root, you remove the root sign, because squaring makes it bigger, rooting makes it smaller, and they divide each other out. So root 13 times root 13, you can check it in your calculator, that will give you 13. So you are left with root 13 over 12, which would be the secant of this right triangle. Now that's our week. We just took a quick look at trig functions. I will post the complete note sheet with answers, but I'd like you to try it yourself, because if you just copy down my answers, it's not really helpful. But if you try to do it, and then I'd like to give you the key just to check, it's better to try to do it yourself so that your brain is working a little harder. Well, it's Friday. Enjoy. This is week 3. Enjoy your weekend, and hopefully I'll see you soon. Bye-bye.